Hello, everybody. I'm back. This was the fifth problem on the notes. I ran out of some space, so if you still keep working on number 5 on your notes, I had to rewrite this on a separate sheet. So now we're solving a triangle, which remember, solving a triangle means to find all the missing sides and angles. Most of the homework is like this problem. Okay, so the first thing you have to do is definitely draw a picture, and like the picture is essential. So 105 degrees here, 23 has to be across from the 105, okay? If you don't get this in the right place, you're not going to get the problem right. And then the other two can just be A and C, the other two angles. 14 has to be across from angle A. Okay, so you really don't have much of a choice here with what you're finding first. You're gonna find, so go to set up your law of sines. So remember, angle and side that are across from each other. And since you have that side length, you have to find that angle first. You have nowhere else to run here, okay? So sine of A over 14. So once again, what do? Cross multiply. So 23 sine A equals 14 sine 104. Oh, excuse me, 105. And then divide both sides by 23. You're going to get sine A equals some nasty decimal. Okay, so let's do that. Okay, so this is what you get when you do that. But remember, that's equal to sine A. So 0.588 approximately, but you wanna keep the unrounded version on your calculator. So look at that thing again. Remember, what we're solving for angle A. So how do you solve for angle A? You do inverse sine of this whole thing. Okay, so I'm just going to do sine inverse of the answer because we should all be using unrounded versions here to get the most precise answer. And it says round to the nearest degree on the angle, so I guess let's just do 36 here. Okay, so if you want, you can label that in the picture. And this becomes actually pretty easy because you can find angle C by adding those two together and subtracting it from 180. So angle A equals 36. Angle C equals 39. Okay, so you have the two angles. So now what do we need? We still need one more side length. So you'll set up another law of sines using that angle, that side. So sine of 105 degrees over 23. But what do you still need? Let me mark this in the picture. You still need side C, little c. So you're going to do sine of 39 degrees over C. Cross multiply. Divide both sides by sine 105 to solve for lowercase c. Stackable fraction. Oops, let me write that. Let me put that there. 14.98. So I'll write this up here with all my other information. So remember, if it says solve the triangle, you need to find all the missing sides and angles. And that's what a lot of the homework is like for 9.2. So now let's look at the back of the notes, the second page. These are all the applications. Okay, so let's look at this thing. Everything's in the that's in the problem is labeled in the picture. You need to know that thing, the height. Okay, so when it's talking height or altitude, not an interesting, but a factoid about it is that it's always talking the perpendicular distance. So this is a right angle here. So you could find a couple angles in here. You know that those two are supplementary. They're a linear pair. So this would be 120 degrees right here. And then you could find that one inside this triangle. I'm talking about this triangle now. You can find that one by adding those two together and subtracting it from 180. So let's do that. So this is 15 degrees. So 15 here, 120 there. Let me get in on that a little bit closer. That's 15 degrees up here. This is 120 down here. I'm looking in this triangle right now. So you have that distance right there. You have to work in this triangle first because you only have one side length and it's in this triangle. So you're obligated to work in here first. So you would do sine of 15 degrees over 158, and you could find either that side or that side. It really does not matter. Okay? Either way, you could use either of those pieces of information to get you this. So sine of 15 degrees over 158. I'm going to use, let's see. I'm going to use that angle and that side. Sine of 120 over, you don't know. Okay, you could use any letter here. I guess I'll just use x. So x sine 15 degrees equals 158 sine 120. Okay, how do you solve for x? Remember, x is a side length. So you're going to divide both sides by sine 15. And you'll have your side length. You get 528.678. Okay, so then that's this thing. Let's see, let me just double check. It's this thing. There are a lot of ways you could go about this to find that distance. But what I'm going to do is I am going to work inside the big triangle. There's a lot of ways to do this, you guys. You could have found this side first and then worked inside this triangle to find the height. Okay, I found this side, and so now I'm going to work in the big triangle. So you could actually revert back to regular trig here because this is a right triangle. So if I'm using this big triangle, I can do sine of 45 degrees equals h over what I found there. And you could use that to solve. I'm reverting back to the regular trig definition. So remember, sine of an angle is equal to opposite side over hypotenuse. And in the big triangle, you do have the hypotenuse now. Okay, so sine of 45 degrees equals, you could also continue on using the law of sines because the law of sines will work even in a right triangle. So you have lots of options in this problem. So then how you solve this is you multiply both sides by 528.678 and you'll have the height. Okay, or you could put a 1 under here and say I'm cross multiplying and get h equals that thing. So I'm going to use the unrounded value there. And you get 373 point to the nearest yard, so 374 yards. And I will come back with the last problem.